Okay, we're going to look now at sketching quadratics and the parabolas that result using factorisation. And what underpins this are what these first two lines express, and that is to find the x-intercepts of a parabola, or in fact any graph. To find the x-intercepts, you make y equal to 0. Okay, and to find the y-intercept of a parabola, or any graph for that matter, make x equal to 0. We're going to use that. We're going to come back to that, and with factorisation, we're going to work out how we can sketch the quadratic using x-intercepts and y-intercepts. So here's let's do the first example. Sketch the graph of the following quadratics. So the first one, let's have a look at y equals x squared minus 6x plus 5. Okay, to this point, what we've looked at are just little variations, little transformations. We've looked at, if we did this, then we go, the minus 2 means go right, go right to from 0, 0 to 2, 0 as your turning point. Or if y was equal to x squared plus 2, then that would shove it up 2. If y was equal to 2x squared, that would just make it a bit narrower. All that sort of stuff. This has been transformations. Now we're going to look at, well, here's a quadratic. It's not in this sort of format, is it? It's just a quadratic that we're going to need to graph, and we're going to graph it, we're going to sketch it by finding the intercepts, and as a result of that, finding out what the turning point is, and that sort of stuff. So let's get to work on that. I'm just going to plug in because I'm running out of power, so I'll pause. Okay, so let's pick it up where we left off. What we're going to do is look at sketching this. So what we're going to do is find out what the x-intercepts are. Now, in order to find out what the x-intercepts of this parabola are, I'm going to make y equal to 0. So, right, here we go. So for the x-intercepts, right, make y equal to 0 and solve. That's what we're doing. So let's do that. Make y equal to 0 and solve. So back up here, y becomes 0. So 0 equals, and we're going to solve for this, x squared minus 6x plus 5. Now we're used to seeing it the other way around, so let's do a switcheroo. So it looks like x squared minus 6x plus 5 equals 0, like that. So we're solving this equation. Let's see what happens. Now, in order to solve it, just a little reminder, we're looking for two numbers that multiply to 5, add to minus 6, add to minus 6. Multiply to 5 and add to minus 6. Think that through. It's got to be 5 and 1. Multiply to 5, minus 5 and minus 1, I reckon. So get in there and factorize this. And that's how, remember, we solve quadratic equations, by factorization. X minus 5, x minus 1 equals 0. Just do a little check that you understand that, what we just did there. Just took this quadratic, found the factors for it, right? So now that's equal to 0. The beauty of this now is that it's easy to solve because I make each of these factors equal to 0. So x is equal to 5. When x is 5, I've got 0 here, or x is equal to 1. So we use the opposite sign, don't we? If it's minus 5, it comes down here, it solves to 5. If it's minus 1, it solves to 1. So what I've got now, remember what I was doing, I made y equal to 0, I solved, so these are my x-intercepts. So let's go over and start to have a look at the graph of this. My x-intercepts are 5 and 1. So I'm going to go in here. Remember, I'm just sketching, so I'm not bothered too much about, not bothered at all really about scale, but I'm going to put them on the right side. I'm going to get them in roughly the right place. That is it. So I'm now just going to draw my, just check, it's positive x squared, so it's up. It's concave up, or smiley face up. So it's looking like this. So that's my parabola, put some arrows on the end there. This is the sketch of y equals x squared minus 6x plus 5. I write down my x-intercepts of 1 and 5. I put those just there next to where they cross the x-axis. This being my x-axis, of course, this being my y. Now I need to find my y-intercept, which usually is pretty easy. We'll just make x equal to 0. And making x equal to 0, so go back up to the equation, make x equal to 0, and you go 0 minus 0 plus 5, so it's just 5. So my y-intercept is 5. I'll just go through that again. For x-intercepts, that was quite a big deal because I had to go through and make y equal to 0 and solve for x. I've got to solve this quadratic equation. A few steps involved. But for the y-intercept, you make y equal to 0. I'll just write that out, but I'll pause while I do so. So go back to the equation now. For the y-intercept, make x equal to 0 and solve. So y equals, make x equal to 0, 0 squared minus 6 times 0. See that any term in x just goes to 0 plus 5. What do we got here? Y equals 5. So there's my y-intercept, and it goes in there. Now to find the turning point just here. Now the turning point is going to be halfway between my x-intercepts. So halfway between 1 and 3, sorry, 1 and 5 is 3. So my x-coordinate here is 3. My y-coordinate, I need to put 3 into this equation to find out what y is. So to find the y-coordinate here, I go y equals, and I'm going back to this equation here, 3 squared minus 6 times 3 plus 5. Let's put all that through my brain. 3 squared is 9 minus 18. So I get 9 minus 18 plus 5. So it's minus 9 plus 5, which I think is minus 4. So minus 4 is my y-coordinate at my turning point. And I've got a perfectly executed graph there. I've got all the information I need on there, and everything's good. Okay, I'll do one more example before I sign off, and then leave it to you to do exercise 7c. So I'll have a look at let's have a look at x squared plus 6x plus 9. So this is example number 2. Number 2, x squared plus 6x plus 9. Sorry, that's a y equals. Let's get a y equals in place here. Can't sketch it without a y equals there. So this is 2. So let's go through the process again. For x-intercepts, y is equal to 0. So make y equal to 0. You got 0 equals x squared plus 6x plus 9. Now solve this equation. Switch them around. X squared plus 6x plus 9 equals 0. I'm looking for two numbers that multiply to 9 and add to 6. Alright, have you got them? 3 and 3 doesn't do the trick. 3 and 3. So that means it factorizes to x plus 3, x plus 3. Look at that. That's what we call a perfect square, isn't it? It's a square quadratic. So my solutions are just minus 3. I've only got one solution. X equals minus 3. I've got one x-intercept. So what does that look like? When we do this graph here, that means that at 3, oh no, it's at minus 3, sorry, minus 3, this is where it goes. It goes through there, but it doesn't go through the x-axis, because if it did, it'd have to come back up through another point. There's only one x-intercept. That's at minus 3, so it needs to bounce off there and come back through. X-axis here, y-axis here. This is minus 3 here. What's my y-intercept? I make x equal to 0. Look at that, 0 plus 9. So it's just 9 up there. I've got my turning point because it's right on the axis at minus 3, so I don't need to calculate it. So we're done. So that one's really quick. Actually, if you have a look at this, x plus 3, this is actually y equals x plus 3 squared. And if you want to link this in with what we've just done, what happens when you've got a plus 3 there? It shifts 3, doesn't it, to the left, counterintuitively, and ends up at minus 3 here, so the parabola looks like that. Okay, enough from me. Hopefully that's good enough to get you going now with exercise 7c when we next meet in class. I'll see you then.